This is a CBS News special report. The flight of Apollo 10. Brought to you by Western Electric, manufacturing and supply unit of the Bell System, as part of our continuing coverage of important news events. Reporting from the CBS News Apollo headquarters in New York, correspondent Walter Cronkite.
Good afternoon. Apollo 10 is now on the far side of the moon on its 12th revolution of the lunar body. And this is the critical time behind the moon, because at this time, the two spacecraft should be separating, undocking for the trip Stafford and Cernan will make on a subsequent pass within 10 miles of the surface of the moon, the landing site for Apollo 11 in July. But there has been some trouble aboard the spacecraft, and now at Mission Control in Houston, they're waiting anxiously for the men to reacquire the signal as they come around to the near side of the moon some 13 minutes from now to report on whether they have indeed undocked and whether this mission is to be a complete success or not. The trouble has been in pressurizing, depressurizing the tunnel between the command module and the lunar module. That trouble developed a couple of hours ago. They worked out what they thought was a solution, and then just before they lost a signal to the Earth, it turned out that there was a little more problem than they thought at first, because the two spacecraft were not staying firmly docked as had been planned, but instead there was some pressure on the docking rings, and the Houston control people didn't like that a bit. So they said if that did not get any worse, or much worse, they could go ahead and undock, but to watch it closely. Perhaps we could go out to Downey, California, to North American Rockwell, where the command module is built, and where their test engineer, Leo Krupp, is standing by, and he can tell us just what the problem is. Leo?
Yes, sir, Walter. The problem has been that John Young was unable to vent the pressure out of the tunnel after Stafford and Cernan entered the lunar module. The problem basically is that when the two pilots are in the lunar module and John Young is in the command module, the two pressure hatches are reinstalled. And then if the tunnel has pressure in it, it's tending to force the two vehicles apart. And at this time, the only thing holding the two vehicles together in a dock configuration is the docking probe, which is preloaded to pull the two vehicles together. But with the pressure in there tending to force the two vehicles apart, there's insufficient coefficient of friction between the two docking rings of the lunar module and the command module to prevent the two vehicles from shifting orientation should any roll maneuvers be performed in either vehicle. And this is obviously what has happened, because unable to vent the tunnel down to zero pressure, the coefficient of friction has been low, and I believe the last report from Mission Control has been that the orientation has changed 3 degrees since they originally docked on transposition and docking. And I also understand that they have set a limit of 6 degrees when they come out the other side of the moon here. If they have not shifted more than 6 degrees, they'll be given an okay to undock. Now, the concern here is strictly a structural concern. We could undock at any slippage angle. The problem is the fact that the two vehicles are slipping. We're putting a load on the docking system, on the docking probe. So there will be some concern if we slip past 6 degrees as to whether we have overstressed the probe system or not.
As I understand it, Walter, Leo was just filling me in on some of this. The question is not so much undocking right now as possible damage that might be done these latches and might jeopardize the return when they bring the two back together after Lem's scheduled trips down close to the surface of the moon. Is that right, Leo?
That's right, Bill, and I'm sure the NASA engineers at Houston are looking into this very carefully. At the same time, the North American engineers here at Downey are looking into this, and the decision will be made as soon as communications is reestablished and we know whether there's been further slippage, whether it'll be a safe configuration for undocking.
And of course, the big questions, Walter, are what this kind of problem might do to the rest of this mission, and conceivably what it might do to the plans for Apollo 11 in July.
Well, now, let's get something straight here, Leo. As I understood Mission Control a moment ago, they have, this is the orbit, the revolution of the moon. They're behind the moon now. There is no signal to Earth. And before they disappeared behind the far side of the moon, this was the revolution that they had to undock on on the far side of the moon if they are to make that sweep over the landing site in the same timeline as the Apollo 11 would make it. And that's quite critical for the sun angles on the landing site, which are quite critical there on the moon with its sharp shadows and definitions. Now, they have to do it this time. They got a go for undocking. They will make that decision themselves. There will not be another go from Mission Control in Houston. The constraint that Houston put on them was that if that slippage got up to 6 degrees, they should not undock. So if it's not up to 6 degrees, they will go ahead and undock around on the far side of the moon. And as a matter of fact, should be doing that in about 5 minutes from now. Is that right, Leo, do you think?
Yes, sir. I probably gave you the wrong impression. They were given a limit of 6 degrees of slippage, and when they lost communications, I believe the angle was at 3. So if they do not exceed 6, they'll probably go ahead and undock on their flight plan profile.
All right, now if I can go back again, fellows, and put this in my sort of layman's language, which is befitting of a 6-year-old, the two spacecraft are held together, of course, by these docking rings, these latches that hold them together when the command module and the lunar module are docked. Some of those latches are released in preparation for the undocking of the lunar module, and you've got just the docking rings holding them together. Those docking rings in the 3-foot-long tunnel that is between the hatches at the top of the command module and the top of the lunar module. Those hatches have to be firm and strong, of course, so that the individual spacecraft can be pressurized. In between there, they depressurize the tunnel under normal circumstances so that this pressure that you're talking about, Leo, will not force those rings together in any small maneuvers they make in testing their rockets before undocking, which is what they were doing. But now in testing those rockets, because they could not get all that pressure out and decided to go ahead with, I believe it's 3.5 pounds pressure per square inch instead of the 0 pressure they'd like, they got it down as far as 3.5. But they still got that much. Because they couldn't, when they tested the rockets, apparently there's a shifting between the two spacecraft, which is putting that pressure on the rings. As long as that shifting stays down below 6 degrees, why, they feel it'll be all right, and the pressure on those rings would not be so much as to damage those rings so they could not redock. I don't know if that's simplified it any, but it reads to me. Is that right, would you say, Leo?
Yes, sir. At this time, all 12 of those docking latches are released, so the only thing holding the vehicle together is the preload on the docking probe that's inserted into the drogue on the lunar module. And this shifting, we don't think it's going to probably damage the docking rings any, but it's putting a side load onto the capture latches of the probe, which may prove to be a problem. And I'm pretty sure this is what the NASA and the North American engineering concern is the capture latch of the probe itself, not the docking rings of the two vehicles.
And as to why they have the problem in depressurizing, we'll get to that in a moment. CBS News color coverage of the flight of Apollo 10 will continue in a moment. The problem on this revolution of the moon, which has given some concern to Mission Control, and for which they're breathlessly awaiting acquisition of signal in another 4 minutes, began with the inability to depressurize that docking tunnel between the command module and the lunar module. And perhaps Nelson Benton and Scott McLeod out at Grumman Aircraft in Bethpage, Long Island, could tell us what that problem was.
Walter, the problem apparently started with way back when the vehicles first docked. It's a matter of Mylar to some extent, and so that we can show you a little better what Mylar is, we've got some along with us. Scott, can you go through the problem as well as you can as to what actually happened, what we think happened?
Well, this is the Mylar that we will be speaking about, Walter. If you can hang on to this, I can probably give everybody an idea as to what did happen. Some Mylar was lost from one of the hatches, and this Mylar lodged in the valve, and therefore the tunnel between the command module and the lunar module that this hatch leads to here could not be depressurized. In order to free this and check the integrity of the tunnel and of the two hatches, the command module hatch and the lunar module hatch, what the crew did was they opened the valve here and then opened the valve on the egress hatch that's down below. This permitted the air to depressurize from the lunar module down a considerable amount. Then they closed the valve on the top and in here, repressurized the lunar module, and this gave them a pressure differential or a lower pressure in the tunnel than they had in either the command module or the lunar module. They then checked the pressure across the two hatches and found out that both held their pressure, and therefore this gave them the integrity check they were looking for.
It should be pointed out that the astronauts themselves are in no danger here, physical danger. It's the mission and what they're planning to do that is in danger if they cannot undock as planned. Now, that undocking is supposed to have taken place just 1 minute ago, and we can show you what it looked like if it went off on schedule. That is, if they had not gotten up to that 6-degree differential between the spacecraft and the lunar module. They, in separating the spacecraft, the command module moved back a bit and away. They let the probe go and separate in this fashion. Now they drift apart there to 40 feet and hold that position 40 feet apart, while John Young in the command module gets this look of the lunar module and inspects it. He also takes pictures of it for the record and for study on the ground. Get a good look at it, see that it seems to be in good shape. And it should be in this position that they should be coming around the moon just about now. In about 45 seconds from now is the scheduled time for the acquisition of signal. When they come around the moon and they confirm that they have undocked, they will then be prepared to show us some television pictures according to their schedule from the command module of the lunar module. The only television cameras, the color camera, the Westinghouse camera that we have seen such beautiful pictures from, and a standby RCA black and white camera are in the command module. The lunar module does not have cameras. So we will not see that sweep by television down to that dangerous terrain of the moon to within 10 miles of it, which comes just a little later this afternoon. They make that descent at 4:35 Eastern Daylight Time this afternoon, an hour and 20 minutes from now, if all goes well. Now we should be hearing acquisition of the spacecraft from Mission Control shortly. We're, of course, plugged into Mission Control and waiting for that word. Mission Control, by its telemetry, will get an indication right away as to whether the spacecraft have separated. And then they will get, shortly after that, voice communication with the spacecraft. That's been the normal routine on the circle of the moon. As they come around the moon, they're getting their first glimpse again of that unusual sight, which might be called Earthrise. It is the Earth coming up over the horizon. They're at 69 miles high in that nearly circular orbit. First yesterday, the first reports were that they were in a perfectly circular orbit, then everything had fired exactly, but it turned out that the orbit is just a little bit elliptical, just a little bit off the circle, but not enough to affect the flight. Their only other problem is that they are running 12 minutes behind their schedule, that is of the flight schedule, the events of the flight, because they did not make 3 mid-course corrections, which had been programmed. They were not needed.
Madrid has acquisition now. We'll wait for a good lockup, see whether he comes into acquisition with the television camera on or not.
This is Jack Riley, voice of Mission Control. Madrid has acquisition. Madrid is one of the 3 big ground stations with their 85-foot in diameter antenna dishes each of those placed strategically around the Earth.
And we got him right away, Tom. Hello, Snoop. How you doing?
Snoopy, of course, is the lunar module.
Hi, Snoop on high gain. How you reading us? Bye-bye. Reading you loud and clear. We're about 30 or 40 feet away from them, but station keeping for about 5-10 minutes here.
They separated.
Could you give us poo and data? We got a load for you, and you're ready to copy some pads.
They have separated. You're hearing John Young from the command module. So you got them 30 or 40 feet away from him, just where they're supposed to be. Separation took place. Those were some long minutes, mission control.
And I'm ready to copy. Roger, Gino, it's DOI's first pad, and we got 3 pads for you, starting with DOI. I'll read them all through all of them, and then you can read me back, okay? Okay, it's DOI 0 9er. Go ahead. 0 9er 9er 46 0 0.
These are the times for the next maneuvers, and they're getting those cleared away before they go to this television.
9er 9er.
They're giving the time for DOI. That's the descent orbit insertion. And that time of 99 hours, 46 minutes, and 2 seconds translates into 4:35 p.m. Eastern Daylight Time. While they're going through these checks, CBS News color coverage of the flight of Apollo 10 will continue in a moment. And from Mission Control in Houston, they're reading up corrections on the timeline by a few seconds of when they will go through their most important maneuvers of this whole flight. And here is a picture from the command module.
Okay, John said he's not reading you. While I'm copying this, he said he's got a picture of the LEM if you want to look at it on TV. We have it, Gino. We're ready to continue with Noun 81 if you're ready. I'm ready to copy. Go ahead. Plus 0.
Houston clearly wants to get these the nuts and bolts of this flight out of the way before they look at pictures.
Minus
What we can see there, he's obviously got the camera mounted in the window as John Young goes ahead reading off or taking off these figures from the ground tracking stations as to the times of the maneuvers to come. Maybe Leo Krupp out in Downey can tell us what we're seeing through the window there at the moment.
0 1 6 7 5.
I believe John has that TV camera mounted in the right-hand rendezvous window, and what you're seeing is the lunar module flying in close proximity. I believe he's going to move out about 25 or 30 feet. And as soon as they get this pad copied, they'll probably go into their inspection of the lunar module, and Tom Stafford will maneuver the lunar module around so we can look at all sides of it.
Got any idea what that is we're seeing right there, Leo?
No, I can't quite make it out on my monitor, Walter.
No, I can't either here. Some external part of the lunar module, quite obviously, but what it is, I can't make out either. They said they were about 35 or 40 feet away, which is where they're supposed to be. They're, of course, at this point, making 5,700 miles an hour around the moon and station keeping at that close distance. That it was a rather exciting 2 hours and 15 minutes from the time that they...
Okay, Charlie, I got everything except Delta VX on 981.
From the time that they first discovered the pressurization problem until the signal was reacquired coming around the moon this time, and it was confirmed that they were able to undock. And now for the big part of this program later this afternoon.
Let me try to raise Charlie Brown. Charlie Brown, Houston, over.
Trying to talk to John Young.
Charlie Brown, Houston, over.
Houston, this is Snoop. He's reading you loud and clear.
Roger. He's copying the pads, and we're not reading him at all, Snoop. And I'm ready with the PDI board pad if you're ready to copy, over. Okay.
For some reason or other, the ground...
PDI board, go ahead.
Mission Control in Houston,
1 0 0.
we of the television audience are not hearing Charlie Brown. the code name for the command module in which John Young now is flying alone. His companions of Apollo 10 are there in that lunar module you see from the right-hand window of the command module. That is called Snoopy. Characters out of Charles Schulz's popular cartoon. You can see down the lower left-hand corner those 10 magic steps to the moon that will be descended on the next lunar module to fly around the moon, Apollo 11, by the Apollo 11 crew when they land on the moon in July, if all continues to go well with this flight. In other words, the lunar module that we see there is canted over about 45 degrees, the top of it heading up to the upper right-hand corner of your screen, the lower part of it down to the lower left-hand side of your screen.
Is 15 seconds at 10%.
We can make out much more of it here now, of course.
Until completion.
You can see the dividing point between the upper stage and the lower stage. The two astronauts are in the upper stage. The lower stage is not inhabitable. They remain in the upper stage, and in the lunar landing, that lower part stays on the moon's surface, and they blast off from it as a launch pad. They will do the same thing on this flight, but make that separation at the 11-mile altitude. They'll be on the second revolution of the moon and their second pass within the landing site. That time scheduled this afternoon for your benefit again is that after this television look at the lunar module, then they go back around the far side of the moon again, and I'm listening to mission control for a moment, but the lunar module fires their engines at 4:35 while they're in the far side of the moon. We will not have a signal when that happens. They descend then as they come around the moon on the near side again, down to that 10-mile altitude. They reach that point at 4:35, at 5:47, that is. 4:35, they fire the engines for the descent. They make that descent the near point at 5:47. They fire the engines again at that point to go into a very high orbit out around the moon. Puts them out 200 miles above the moon on the far side. They swing around the next time. They come down within 11 miles of the lunar landing site 2. They're at the Sea of Tranquility. And this time, when they fire to rejoin the command module and to rendezvous with it and to dock later tonight.
455 plus all balls, plus 00011. 00931, 022,
Scott McCloud, out at Grumman, we've been listening to this read-up of these figures back and forth. We heard from Tom Stafford saying that John Young could hear him all right, but apparently John Young's transmission to us was lost for a while, to the ground, that is. What are they doing in the lunar module at this moment?
Well, at the present time, they're preparing to make their maneuvers, probably, around to show the command module all sides of the lunar module, a complete check. As you recall, they have already opened the landing gear. It has been deployed. You can, I think, on the monitor that I have here, see the forward gear, and I think you pointed out the ladder going down. These numbers that are being read to them are the numbers that they will enter in the computer and the numbers that they will be checking to make sure that they perform all of the burns correctly, that their updating is proper.
Scott, it's going to be the lunar module that does the turning around, the little pirouette there for Charlie Brown, dancing out in front of him. He's going to remain steady with the television camera, and it's the lunar module that's going to do the performing.
Yes, that's correct. Very similar to the way they did in Jim McDivitt's flight.
Right. It should be pointed out that the space people have grown exceedingly confident of their engineering skills. This is only the second flight in space of a lunar module. It's the first, of course, in the moon environment with its strange gravitational anomalies, in this deeper space in which the command module must re-rendezvous with the lunar module, or these fellows have no way to come home. It's a critical flight in every sense of the word.
With the CSM, we're losing his, we got the downlink to Goldstone, but we're not getting it here in the MCC.
Houston reporting these communication problems.
This column has got to be fixed in the next couple hours, Charlie, so tell them to get with it.
Roger.
That was Tom Stafford, commander of this flight, showing a little annoyance. Saying everything's looking good there, but annoyed with this ground link communications problem. You just heard Mission Control say that their Goldstone, which is the tracking station in California, is getting the downlink, that is the transmissions from Charlie Brown, from John Young in the command ship, but they're not getting them in Houston. So it's obviously...
Houston, it's Snoopy. Is that 69.2 by 57.5 good? Stand by.
The problem is in some part of the ground link communications.
Snoop, Houston, we aren't with you on the 69.2. Say again. I'm reading verb 82 out of the Disky, 69.9 by, or 62.9 by 57.5. Stand by, we'll have it for you.
They're confirming their orbit remains the same after their separation maneuver.
Snoop, Houston, Fido's checking, stand by.
They want the read up from the ground.
Houston, that's a go on the Apogee Energy. I saw. Okay.
Their apogee, or apolloon, their highest point over the moon, is a little bit higher than the circular route they had expected.
About 7 minutes away from the separation burn.
Their low point, their perigee, or now that we're around the moon, they refer to it as paraloon, is about right, but they're a little high on the far side of the moon. It does not affect the flight.
We're steady out here on the station, keeping John, once we got squared away on our attitudes. Okay.
Snoop, Houston, we got a beautiful picture out there of the... Roger, I will. I'll mark it 6 minutes. Charlie Brown,
Okay,
we finally got you, over. Oh, that wasn't 6 minutes.
What was it, Jose?
Okay, I got 5 seconds to 6 minutes.
Okay.
Okay, 6 minutes and counting down to 7.
That's babe.
Charlie Brown, Houston, we're reading you 5 by now, over. Roger. I got 5 minutes and 45 seconds to 7. 44, 43, 42. We're right with you. Houston, this is Snoopy. With that drift you saw, how do you expect our platform to be? How close to good alignment? Right, we expect very small torquing angles in all axes, over. That's good to hear, thank you.
The platform alignment is
We
the...
can get back on the nominal after that installation kind of goofed us up, Charlie, but everything's looking good here.
That's Stafford.
Roger, Tom, could you, one question on the tracking light. Have you tried it?
Stand by. John, here's the tracking light for you.
Yeah, please turn it off.
It works.
Great, thank you. We saw it.
This is Air Force Major Charles Duke, who is the capsule communicator, one of the later class of astronauts.
John, why don't you toss on your tracking light for a minute?
Stafford asking John Young to try his tracking lights. Tracking lights needed for the rendezvous, for the visual portions of the rendezvous. They are brought together.
Roger, that's mine.
By radar.
Maybe underneath the vehicle. I don't think you can see it.
Yeah, I saw one reflection there. We're okay.
But in the closing moments of the rendezvous, it's nice to have those lights on there. We haven't heard, because of the communications problem from John Young as to whether he expects to work with the camera a little more than this, or when. Obviously, there's some tuning up that could be done there. We see the lunar module against the darkness of space, not against the reflected light of the moon. The command module is below the lunar module at this point. Young will be very shortly, in a couple of minutes from now, firing his engines to separate further from the lunar module. And there is a checkout procedure involved, of course, in getting ready for that.
Okay, John, looks like about 2:30 coming up to set, babe.
Roger, agree.
If you can pass on to our support divisions, this Hasselblad sound box has failed about 3 or 4 times on us.
Roger, Snoop, we copy.
We're still getting some pictures, though. The basic camera's good. It's just a packing of a film and a magazine.
Roger.
Stafford talking about his movie camera. Got a little trouble with it, apparently. The command module fires really very briefly, just for about 7 seconds. 6.9, I think it reads in the flight plan. And the separation maneuver is only at it's less than 2 miles an hour, 1.7 mile an hour, just enough to drift apart really a little bit further to give the lunar module plenty of clearance.
Separation maneuver, Will.
When he gets ready to fire his descent propulsion system engine, which is considerable more.
Okay, Houston, coming up on 2 minutes to set. I'm going to sync, Mark. Roger, we copied 1 minute. Raj, you're right. Big brother's watching.
Command module mentioned that they had 2 minutes to the burn, and Houston corrected them to 1 minute.
You'll never know how big this thing gets when there ain't nobody in here but one guy.
We're hearing from John Young. That was John Young.
You'll never know how small it looks when you're as far away as we are.
That was Cernan. John Young said, "You never dream how big this thing gets when only one guy's in it." And Cernan answered, "You never dream how far away it looks." They've got to get back to that command module later tonight in order to get home. The lunar module cannot make the return trip to Earth. It presumably could make it with the firing of the descent propulsion system engine, which has a power up to almost 10,000 pounds thrust. But that would get them out of lunar orbit all right, but they have no way to re-enter.
You can see your thrusters flying there, John, and you're moving away.
Okay. Show 5.3 on the disky and 5.0 on EMS and on 0 on EMS. I'd be inclined to believe the EMS today. We copy, Charlie Brown.
Okay, Jose, so adios, and we'll see you back in about 6 hours.
Boy. Suit and Charlie Brown, we see you separating on the big tube. See you, John Evans. All right. Have a good time while we're gone, Dave.
Don't get lonesome out there, John.
And don't accept any TEI update.
Trans-Earth injection
Don't
update.
you worry. Till you get back, I ain't copying any more pads.
What they're referring to is that John Young shouldn't change his return time to Earth such that they wouldn't get back. In other words, don't accept any TEI updates and come back to Earth before they get back and rejoin him.
Houston, this is Charlie Brown, over. Go ahead, Charlie Brown. Roger, while we were waiting to come over the hill, we checked out VHF, and we're right now on VHF AMA and receive only B data. Beautiful. It sounds good. Thanks a lot.
John doing something with that camera. You saw his hand coming of it, and he's moving it around. Whether there's going to be more television on this pass or not, we don't know. It wasn't scheduled to be much longer than that, and the lunar module is obviously getting rather dim in the picture. So all is going well with the flight of Apollo 10. Now 2 spaceships circling the moon. That has never happened before in history. In the manned space program, this is another first. 2 manned spaceships now flying there just a few miles apart. They'll eventually get as far as 350 miles apart when the lunar module goes into its high orbit on its second pass alone around the moon, out to some 212 miles above the moon, before it sweeps down to within 11 miles of the moon at 3,700 miles an hour on its second pass over the lunar landing site for which the Apollo 11 astronauts will be aiming. It's about 6 hours that they'll be apart. As you heard John Stafford say, we'll see you in 6 hours, John. Talking to Charlie Brown, John Young, who now flies alone in the command module. He's got a mighty important job to do, because now with each of the maneuvers of the lunar module, he does mirror image burns or preparations for them, so that at any time he can go to rescue the lunar module if it cannot come back to him. If all goes well, he stays in his roughly 69-mile high orbit of the moon, and the maneuvers are performed by the lunar module. But should, by any chance, they be unable to perform their maneuvers, he has the capability to go get them. But to do that, he must play every maneuver with them in reverse, be prepared at any moment to do what they cannot do in, of course, reverse to get back to them. And flying around in orbit like this is not just a simple matter of driving on Earth, of course, in a single plane. They're working in 3 planes here at all times, and it is highly complicated, and with the orbital speed involved as well. They're always moving at that orbital speed of around 5,700 miles an hour around the moon, and the maneuvers must be performed so that they calculate that speed and still speed up and slow down individually to rejoin. This is the maneuver they're undergoing now. They're making this the 13th revolution, 12th revolution of the moon. They're on the near side. If we had binoculars powerful enough, we could see them crossing right in the middle of the moon, right at the equator, as they make this revolution of the moon in these 2 spacecraft. The actual redocking comes 8 hours and 8 minutes after the undocking. they begin the rendezvous procedure, and they really begin to separate. They begin to separate, and then they come back and they rendezvous, and the total time that they're really apart, far apart, is 6 hours in there. And so after a very tricky problem earlier today, they managed to get this undocking, to go ahead with the mission, and now the trickiest part of the whole mission begins. This was the first flight in space that really requires such detailed pilot skill that the slightest miscalculation could be disastrous, because Tom Stafford and Eugene Cernan have to eyeball this flight, as well as depending on their radars. The radar, of course, has never been asked to do the job. It's going to be doing it this time in the lunar environment. We do not know what the effect of those mass cons, the concentration of mass under the moon's surface, could do down at 50,000 feet. There are moon ridges and volcanoes, extinct, of course, mountain sides that they're going to have to avoid as they come in for that landing area. And that's the idea of this whole thing, to get down there and find out how difficult it is to get down before man commits to actually make the landing on the moon in Apollo 11. As Tom Stafford said yesterday, after they got their first real look at the moon's surface and then gave us that extraordinary look in the television transmission last night, it's going to be a real trick to go down among those mountains tomorrow. Well, today is tomorrow, and the real trick time has come. The timeline, let me give it to you once more as to what is going to happen here this afternoon. It is now Eastern Daylight Time, 3:43 p.m. Well, at 4:35 p.m., they fire their engines on the far side of the moon. They, again, are out of touch with the Earth. We won't know until they come around it'll be 35 minutes later that they have performed that function properly. That's when they fire their descent propulsion system engine for the first time and go into that orbit which will bring them down within 10 miles of the moon at 5:47 p.m. We'll be back for those maneuvers to report them to you from the CBS News Space Center. This is Walter Cronkite at the CBS News Space Center. Good afternoon.
This has been a CBS News special report, The Flight of Apollo 10, brought to you by Western Electric, manufacturing and supply unit of the Bell System, as part of our continuing coverage of important news events. Next Apollo update in 45 minutes at 4:30 Eastern Time. This is CBS.